Alright guys, in this lesson we are going to be talking about how the universe came to be, how we know how the universe started, and talking about the evidence behind that. So let's start by looking at waves. Alright, we're going to try and make some waves. Okay, so I froze it. We have a good picture of a wave, and I'm going to draw it with red so you can see this. It comes from my hand, down, up, all the way like that. And there's a couple of terms I want to get across to you guys. First term is wavelength. That's the distance between the wave and the wave, the peak of one wave and the peak of the other wave. So if I have something that goes like this, then the wavelength is very short. If I have something that's really long, then it has a very long wavelength. That's all that means, okay? The other thing I want to talk about is frequency. Frequency, I like to think of it like this. If this is a wave hitting the beach of the ocean, how frequent do the waves crash on the shore? So if this is the shore over here, frequency is just how often this wave hits the shore. If it's hitting once every second, then we have a frequency of 1. If there's 2 waves hitting every second, then we can say we have a frequency of 2. Right? And we can keep doing that. We don't really call them, waves per second, but we really say hertz. That's the frequency we use. So saying like 10 hertz is kind of like saying 10 waves crash on the beach every second, or every unit of time. So these are important terms to understand, and I'm going to tell you why. Here we go. Okay, first things first. You need to know who this guy is. Ready? His name is Christian Doppler, aka the Doppler effect. And what he did is he noticed that when an object that a wave is coming from, the wave is propagating from an object, if that object happens to be moving towards the source, then the frequency increases. Alright, if it's moving away from the source, the frequency decreases. Let me show you what I mean by that. Hold on a second. Okay, so if I'm producing, there's a wave propagating from me like this, and say like the frequency is 1, right? And then all of a sudden I do this. Then what happens is the waves get compressed, right? The wavelengths get shorter, and the frequency goes up. It's kind of, the waves are crashing on the shore more often because I've compressed those waves. And the same if you're running away, the waves get stretched, and the wavelength gets longer, the frequency gets lower. So what Doppler noticed about this was that if a train is coming at you, sound puts out wavelengths, right? Sound waves. And if the train is coming towards you, it's coming really fast and the waves are coming out in front of it, the train speeds and compresses the waves. So when it comes to your ear, they're hitting your ear with more frequency. The wave is hitting really fast, right? And that causes it to be a more intense sound. And as the train goes by you, here's you, the train goes by, those waves get stretched, making the intensity or the frequency get lower, and so you get the effect. Like that sound effect? That was pretty nice. Okay, so next, you understand the Doppler effect. Now we need to talk about this guy. Hold on. Yeah, there we go. He has a very nice hairdo. His name is Isaac Newton, right? Now, Isaac Newton did a lot of really cool things. We're going to talk about him all year long. But one of the things he did is he studied optics, how light behaves. And what he came to find out was that, actually, light is made up of the rainbow. Roy G. Biv. He did a really cool experiment. He took light from the window. It came in through the window. He passed it through a prism, and it made a rainbow on the floor, right? And he said, well, the white light, it's made up of Roy G. Biv. And then he passed the Roy G. Biv through another prism, and it turned it back into white light. So he was able to prove that white light is made up of these individual colors. And when they all mix together, they just make white light. So ultimately, what he came to as a conclusion is that light is, and we know today, is a wave. And each color of the spectrum is a different wavelength, right? Red is a very long wavelength, very low frequency, and orange gets a little shorter, yellow a little shorter, until you get to the blue, indigo, and the violet. Indigo-violet. Where I come from, we call it purple. The purple has a very short wavelength, very intense, boom, 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 high frequency. All right, so now take what we understand about this first guy, remember him? Doppler, and incorporate the sound waves into light waves from Newton. And what we can come to is that if an object is moving towards you, then you would expect the waves to get compressed and you'd see more of the red colors. And if it's moving away from you, you would expect the waves to get stretched and you would see more of the blues and purple colors. So this is very important, and let's go into some more detail on this. Hold on just a second. Alright, so let's try to wrap this story up a little. I've been talking about this guy named Christian Doppler and Isaac Newton. I want to talk about one more guy, and we'll look on the big board here. There he is. A little bit more modern. His name is Edwin Hubble. You might know him because they named this big flying thing after him out in outer space, the Hubble telescope. And one thing that he did to kind of wrap this all up is he started looking at galaxies through spectroscopes. A spectroscope, here's my 50-cent version, is this little thing you look through, and it breaks white light up into the spectrum, the rainbow, right? And it does it in a very specific way. It does it like almost like a fingerprint. It tells you what things are made up of, but that's not really what I want to get into. When he was looking at distant galaxies, he noticed it left these little spectral lines, and I'll show you what I mean by that. Hold on a second. That thing right there is Krypton. Yeah, Superman was around, trouble. All right. It's Krypton in a tube. And if you look at it through a spectroscope, you'll see very specific spectral lines. So let's pretend like this is you, and I'm going to put this over your eye. And what you will see, ooh, there it is, the spectrum. What this has done, this little spectroscope, isn't that cool, is it's taken Krypton and it's broken it up into very distinct spectral lines. You can see a yellow line and a green line, kind of a fuzzy red and blue line. Alright, so that's kind of cool, and Edwin Hubble was looking at galaxies, and he would look at it and mark the spectral lines. Then he'd come back maybe a few days or a few months or even a year later and look at that same galaxy, and what he noticed is all those little lines were shifting, they were moving, and they were all moving mostly towards the red end of the spectrum. And he got thinking about this, and what does this mean? And ultimately, what he came up with was, those galaxies he was looking at are moving away from us. And because they're moving away, just like a train going by us, it's stretching the wavelengths of light. And like I told you earlier, from what Isaac Newton looked at, the blues and the purples are a much more compacted wavelength, and the reds are stretched. So Edwin Hubble looked at all these galaxies, and he noticed all the galaxies are red shifted, meaning that all the galaxies are moving away from us, and we're moving away from them, and they're moving away from each other, and ultimately that means the whole universe is expanding away from each other. Everything is moving apart. This is a great analogy scientists use, like little pieces of raisin in raisin bread, and as the bread rises, the raisins all move away from each other. Well, the galaxies are all moving away because our universe is expanding. What Edwin Hubble did, using Doppler effect, using Isaac Newton's optics, and all the stuff that's built up since then, is he began to prove that the universe is expanding by looking at the galaxies and noticing that all of their spectral lines are shifting to the red side because they're moving away and the wavelength is stretching as they move away. Next piece is this. Edwin Hubble then said, wait, stop. If we could freeze time, and I know how fast all the galaxies are moving away from us, and we back it up, rewind, then we can bring all the galaxies back to one single spot. And that right there, my friends, is the birth of the universe. The singularity, the single spot, is where everything in the universe was once compacted into, and he calculated that to be about 14.678 billion years ago. 14.6 billion years ago, we'll call it, right? And ever since that moment, everything has kind of expanded away and is still expanding today, and the universe continues to expand. We refer to this expansion as the Big Bang Theory. Not the television show, the actual theory. So we'll be talking about this more in class. I hope this is a good primer to get you understanding it. Have a nice night.